Good morning. Yeah.
Good morning, sir.
Okay. So write this question. 5.28.
Done, sir.
Okay. So here the object is pentagonal pyramid. And where is the cutting plane? Cutting plane.
Inclined to VP.
Yes, cutting plane is inclined to VP. Okay. So the inclination is 30 degree, right?
Yes, sir.
Okay. So the cutting plane is inclined at an angle of 30 degree and cuts the axis 20 away from the base. Okay. Then here the pentagonal pyramid resting on one of its long base edge on HP and the axis is perpendicular to VP. Okay. So I will draw the quadrant, first quadrant. So this is my HP and this is my VP, and here this pentagonal pyramid resting on one of its base edge. So this is my base edge, and this is my pentagonal face. This is my pentagonal face, and this is my apex. Okay, so this is my apex and the axis. So this center line is my axis. So axis is perpendicular to VP. Sorry, axis is perpendicular to VP, correct? Yeah, yeah.
Yes, sir.
Okay, so axis is perpendicular to VP. Okay, so here the pentagonal pyramid resting on one base edge on HP and the axis. So this center line is my axis. So this axis line is 90-degree perpendicular to VP. So here, what is the front view? What is the front view?
Mm.
Front view.
Front view is the pentagon.
Yeah, front view is a pentagon. Because why? Because the axis is perpendicular to VP. That means front view is a pentagon. You can see a pentagon in the front view. Then what about the top view?
A triangle.
Yes, top view is a triangle. Okay, draw the front view and top view. So front view is a pentagon. So this is my front view. Front view. Draw a pentagon. Front view is a pentagon and the top view is a triangle. Top view is a triangle. So what about this distance here from XY line to this base? What about this distance?
Any distance.
Hmm?
It can be any distance.
Any distance. Correct. Okay. So I will name I will name this as A dash, B dash, C dash, D dash, and E dash. And in the top view, so this is A, this is E, this point is B, then this is D, and this point is C, and this point is my apex M. So here this is M, apex M. Completed? Over? Yeah, yeah.
Yes, sir.
Okay. Then
Done, sir.
okay, okay. So then draw the cutting plane. Okay. So here the cutting plane is inclined 30 degrees. See, 30 degree to VP cuts the axis 20 mm away from the base. Okay. So this is my base. Correct? A, B, C, D, E. This is my base. Okay. From this base, you have to mark a point here in the center line because that means the axis line, center line, center. Okay. So the distance is 20 millimeter, but here in the textbook you can see they have marked 18 millimeter. So that is wrong. 20 millimeter. In the question it is given that the distance is 20 millimeter away from the base. Okay. So mark a distance of 20 millimeter from the base. Okay. Then, so this is my point. Okay. So through this point, you draw a line like this parallel to XY line. Then take this angle 30 degree. Okay. Take this angle 30 degree. So place your protractor like this. Okay. Place your protractor like this. 10, 20, 30 mark. 10, 20, 30. Then draw a line. Draw a chain line with the ends thick. Not straight continuous line. Draw a chain line with the ends thick. So this is my cutting plane. So draw a chain line like this and the ends thick. Okay. So this is my cutting plane. This is my cutting plane. 30 degree, 30 degree to VP. Okay. Yes. Then tell me how many cutting points.
5.
Okay, 1 minute. Okay. So 5. Okay, I will check. Wait. Okay. Okay. So here I will change the color. 1 minute. I will take red. Okay. So here one slant edge, here another slant edge, here another slant edge, here another slant edge, here another slant edge. So that means total 5 slant edges. Okay. So MA, then ME, then MB, then MD, and final one MC. So these are my 5 slant edges. Okay. So I will name the visible slant edge first. Yes, tell me, yeah, here, which slant edges are the visible slant edges here? Visible means, so this is top view. So this is my top view, and this is my front view. Okay. So in the top view, which all edges are the visible slant edges? So this is my top view direction. Okay. So this is my top view direction. Okay, when I look from this side, you can see the top slant edges are MA, MB, and MC. Is this clear? MA, MB, and MC.
Yes, sir.
Okay, so I will give MA cutting point number one on slant edge MA one. Then next is 2 on MB and 3 on MC, because these three are the visible visible slant edges. So I will give one here, center here, two here, three here. One, two, three. Okay. Then from that point, go back. So this is point number 4. Okay, point number 4 is on MD. Then this is point number 5. Point number 5 on ME. So okay, so this is the cutting point marking. Okay, so 1, then 5, then 2, 4, 3. Okay. So 1, 2, 3 visible slant edges, then 4 and 5 invisible. Invisible means you can say dotted line. Okay. So invisible slant edges are ME. See, yeah, this one M dash, E dash, and M dash, D dash. So these two slant edges are at the bottom, whereas MA, MB, MC are at the front side. Okay, then you have to, then next step is very simple. Transfer these points to the front view. Okay, transfer this. So 1 to MA. So I will project 1 to MA. MA means M dash A dash. So I will project 1 to, yeah. So this is This point is 1 dash, 1 dash on M dash A dash. Okay, where is point 2? Yeah, here. Where is point 2?
Point 2 is on MB.
MB. Okay, but here what is the problem?
It's vertical.
It's vertical, so it is very difficult to locate the point 2. Okay, in that case, the step is like this. First, you have to transfer the top view point to the true length of the slant edge. Okay, so I will clear this first. Okay, then only you can understand. Okay, okay. So first you draw a center line through the apex in the front view. Okay, then take this as center. The slant edges radius, draw an arc to this center line. This as center, and this any slanted just radius, draw an arc. Then project that point to the baseline. So this is my baseline, and then join this point with the apex. So this is my true length of slant edge. True length of slant edge. True length of slant edge. Then transfer my point 2 on this 2 on this true length, and then project this to the center line in the front view. Then take this distance, draw an arc here. So you will get 2 dash. Clear? Yeah, yeah.
Yes, sir.
Okay. Then mark all other points. All other points very simple. Just project it and then join. You will get the section. Draw 45-degree lines. This is called hatching. So this is my sectional. This is actually front view. In this front view, you can see a section here. So this is my sectional front view. This is my sectional front view, and this one is my top view or plan. Okay. So in the question you can see, check the last sentence. Draw the top view. So this is my top view. The sectional front view. So this is my sectional front view. Front view with the section, that is called a sectional front view. Front view with the section, that is called a sectional front view. And here the section is true or apparent. Yeah, here true or apparent.
It's apparent.
Apparent. Why? Because cutting plane is inclined, right?
Yes, sir.
Okay, then draw the true shape. Okay, draw the true shape. Okay, so first draw a new reference line. First draw a new reference line. So this is my new reference line. So this line is parallel to the cutting plane. So this is my cutting plane. So this is my cutting plane, and the new reference line is parallel to the cutting plane, and this distance you can take any convenient distance. Any convenient distance. Then draw projection lines from the cutting points. So when you draw the projection lines, yesterday I told you, very careful. So the projection lines are parallel to each other, and projection lines are perpendicular to the reference line. Projection lines are parallel to each other and perpendicular to the reference line, perpendicular to this new reference line, perpendicular to this cutting plane. Okay. Okay, so I will name once again A dash, B dash, C dash, D dash, E dash. So this is A, D, B, sorry, not D, E. So this is E. I will erase this. Okay. So A, E, B, D, and C. Okay. So this is 1, 2, 3, 4, 5. Okay. So here this is 1 dash, 2 dash, 3 dash. Okay. And this one is 4 dash, and this is 5 dash. Okay, so first take this distance from XY line to 1 dash. Yes, tell me, yeah, here, what is this distance? XY line to 1 dash. XY line to 1 dash.
17.
17, okay. So take 17 mm in the compass. Center is my new reference line. Okay, this point is my new reference line, and cut here. So this point is 1. This point is 1. Then XY line to 2 dash. What is the value?
25.
25 mm. Okay, so take 25 mm in the compass. 25 mm. Okay, and this is my point, because this center line is the line, 2 line. 2 means cutting point, 2 line. Okay, so this is center, cut here. So I will get 2 here. 25 millimeter. 25 millimeter is the distance. Then XY line to 3 dash. What is the value?
Which point?
XY line to 3 dash, 3. Third point, 3. 1 dash, 2 dash, 3 dash. 3 dash means this
1.8. 118.
18. Okay, so 18 millimeter. Okay, so take 18 millimeter in the compass. This center, cut here. So you will get 3 here. Then next point, XY line to 4 dash. That is equal to XY line to 4 dash. Yes, tell me, what is the value? XY line to 4 dash.
5.
5. Okay.
Yes, sir.
Yeah. Okay. So this point as center, cut here. So this is 5. Sorry, 5. So this point is 4. Sorry, this is 5 millimeter distance. This is point number. This is point number, cutting point 4, and the distance is 5 millimeter. Okay, I will write here. Okay, so this is 4. Then XY line to 5, 5 dash. XY line to 5 dash. 6 or 7, 8. How much?
8.
8. Okay. So XY line to 5 dash, 8 millimeter. Okay. So take 8 millimeter radius. This point center, cut here. So this is 5. Okay. So then join all these points. Join all these points. 1, 2, 2, 3, 3, 4, 4, 5, 5, 1. Then draw hatching line. So this is my true shape. This is my true shape of section. Okay. So then mark all the dimensions. 20. 20 is the side of pentagon. Then the height of this object is 45, and this distance is cutting plane distance is 20 mm from the base. Then this inclination, cutting plane inclination is 30 degree. Okay. So right here, so this is true shape, TRUE, true shape, SHAP, true shape. And here write sectional in capital letters, sectional front view, sectional front view. And this one, this is my top view. So this is sectional front view, top view, and this is true shape. Mark all the dimensions because dimensioning is very, very important. 20, 45, 20, 30 degree. Finished?
Almost there.
Mhm.
Done, sir.
Okay. So next problem I will give homework.
Done, sir.
Okay, okay, 1 minute, 1 minute. Okay. Okay. So this question, write this question. Example 5.30.
Done, sir.
Okay. So here the object is here the object is hollow square prism. Hollow square prism. Yes. Tell me the dimensions. Dimensions of hollow square prism.
Um, 25 millimeter base side.
Okay, so base equal to 25 millimeter. Then what about the height?
Height is 55.
Okay, then
Um, 5 millimeter thickness.
okay, then thickness. Thickness is equal to 5 millimeter. Okay, so that thickness means, see, this is my, this is the top view. This is the top view of hollow square prism, and this is the base side of the square, 25 millimeter, and here this is the thickness. Okay, so this thickness is 5 millimeter. This thickness is given, that is 5 millimeter. Okay, then the height is given, height is equal to 55. So this is the height is equal to 55 millimeter. Okay, so here what is the top view? Yeah, here what is the top view? Here the object is a hollow square prism. So what is the top view?
Um, it's there's two squares.
Okay, two squares. Okay, then front view.
Front view is a rectangle.
Yeah, front view is a rectangle. Correct. Okay, then here the square, the hollow square prism is resting on HP. Correct. Resting on its base on HP. Correct.
Yes, sir.
Okay, and equally, and with the base sides equally inclined to VP. What is the meaning of that? Equally inclined to VP. Base side equally inclined to VP means,
It's 45 degrees.
yes, that means this inclination is 45 degree. This inclination is 45 degree. Okay, so this is my, so this is my base side, and this is the second base side. Okay, so these two sides are equally inclined. Base sides equally inclined to VP. So equally inclined to VP means 45 degree to VP. So this inclination is 45 degree. This inclination is 40. That means equal inclination with the VP. Then yes, where is the cutting plane? Yeah, here. Where is the cutting plane?
The cutting plane is perpendicular to HP.
And cutting plane is inclined to VP, right?
Inclined to VP and
But
cuts the prism into two halves.
yeah, but what is the value of angle inclination?
Uh, um, 45.
Okay, so actually that value is not given. So here the condition they are given is that we inclined to VP cuts the prism into two halves, right? Cuts the prism into two halves. So I will mark the center point. So this side is 25, and then I will draw the cutting plane like this. Okay, such that this distance is 25 by 2. Okay, 25 by 2 cuts the prism into 2. Clear? Yeah.
Yes, sir.
Okay, so you have to mark 25 by 2 here, 25 by 2 here, then draw a line. So that line represents the cutting plane. Okay, so this is my cutting plane. Okay, then mark the cutting here. How many cutting points? Yes, yeah, here. How many cutting points?
8.
Yeah, correct. Okay, so eight, total 8 cutting points. Okay, Correct. Okay. So project this to the front view. You will get the sectional front view. Sectional front view. Okay. So here the section is apparent. Here the section is apparent. Why? Because the cutting plane is inclined. So you have to draw the true shape. Okay. So how to draw the true shape? Draw a new line. So this is my new line, new reference line, and that line is parallel to this cutting plane. And this distance, you can take any convenient distance. You can take any convenient distance and project all these points. So take the distance from the front view.